Hello friends, welcome to this channel and let's solve today's problem. So today's problem is leftmost column with at least a 1. So I hope you have read about this problem. If you have not read about the problem, I will just take you through um, what it all says about. So it is about a binary matrix. We are given with a binary matrix, which means it contains only zeros or ones, and also the condition here, it is given that the rows are in sorted order. They are sorted in non-decreasing order, that means increasing order. And now the problem is we have to return the index of the column which has the least index, as well as it contains at least one 1. So it is here. So it is 0 indexed, and we have to return the leftmost column with at least a 1 in it. Now here it says it is an interactive problem. That means we cannot access the binary matrix as it is. To access any element, we have to call these functions binary matrix dot get x comma y. That will give us the element at position xy. And if we want to know the dimensions of the binary matrix, then we have to call this function binary matrix dot dimensions. Now there is one more condition which is very important to notice, is that if we uh, call the binary matrix dot get function more than 100,000 times, so if we call it more than 1,000 times, then it will be considered as wrong answer. So we have to see what it implies for our solution. So here are some examples. If you see in the first example, we have in the 0th column we have got a 1 in it, so we return 0 as the answer. And in the second example, we don't have any ones in the 0th column, but we have a 1 in the 1th column, so sorry, first column, so we return 1. And in example 3, we don't have any 1 in any column, so we return -1. And in fourth example, we have the leftmost column which has at least a 1 in it, is the column 1. Now we have the constraints, which are very important to be noticed every time we want to solve a problem, because they decide what kind of solution we have to approach. So here we have mat.length, and mat.i.length lies between 1 and 100. That means if we have at max 100 by 100 matrix, then we will have 10,000 cells to visit if we want to visit each and every one. So obviously we cannot um, have a big of any square solution here, because for that we need to call this function 10,000 times at max. So in the worst condition, it will be more than 10,000 calls. That will be considered as wrong answer. So what we will do here is that we will take the advantage of the condition that the rows are sorted in non-decreasing order. So for that, what we will do is approach it in binary search manner. So let me just give you a brief explanation of how we will be doing the binary search in this. So uh, let's say we will have a lower index which will point to a zeroth column at first in the beginning, and a higher index which will be pointing to the last column. So we will visit the middle position, low plus high by 2, whatever column that be. We will see if there is any 1 in that particular column. So if there is a 1 in that particular column, that means certainly there will be 1, at least 1 times 1 in every column which has higher index in that, because the rows are in sorted order, and if any one appears in any row, then every next element will be a 1 in that row. So it is very clear that if we get a 1 in the middle position, then there will be no point in finding out for any higher column. So we will go for the columns with lower indices. So for that we will assign the high value as mid minus 1. So let's see how in the code we will do this. So first of all, what we need is that we should know what is um, the size of the binary matrix. So for that we have to declare a vector because it returns a vector. So let's say vector int, let's name it as d. So d will be equal to binary matrix dot dimensions. So this is our dimension. Now we will define two variables, low and high. So high will be obviously the last column, the index of the last column. Now we will apply binary search in the columns. So for that, let's run a while loop. The condition will be low less than equal to high. So now if so now we will have to see which is the middle column. So for that we will declare a mid column position. So that will be low plus high by 2. Okay. Now in this mid column we will traverse through each and every cell and see if it contains even a single one. So let's do that. I is equal to 0, I less than d of 0. D of 0 is the number of rows. So now here we will have to access each and every cell in this particular column. We will have to call that function, binary matrix dot get function. So that returns an integer value. So let's define an integer variable. So we have x as the integer variable and we will store the value of the cell. So okay, so we have got the value at position I comma mid, that is ith row and midth column. So now we will check if this x is 1. If it is 1, then we just break because we need only one. So if we have found x as 1, then we will update, that means we have to go in the lower indices, so high will be equal to mid minus 1, and else if we have not got any 1 in that particular column, then we have to obviously move to the higher indices, so we will assign low is equal to mid plus 1. Now when we come out of this loop, then if there are no ones, then obviously low or high will go beyond the boundaries, that means the boundaries of the indices, like low will go even less than 0, or sometimes even more than the maximum number of columns. So we have to check if low lies between 0 and the highest index value of the column. So if this condition is true, then we will return whatever the value of mid, else we will return -1, that means we have not got any 1. So let's see if this is correct. So I hope, yeah, there is some error. So it says binary matrix does not provide a call operator. Okay, so I have not mentioned the dot get thing here. So let's see. Again there is a compilation error. I'm sorry for this. Oh no, we have to return low because low is what we need. If there is any other error, let's submit. Yeah, it accepted. So hope you enjoyed and learned the session. Thank you.